In this video, we're going to find the difference quotient of a function. So we can ask ourselves the question, what is the formula for the difference quotient? Well, it's going to be f of x. Get my pen, trusty pen to work here. F of x plus h minus f of x over h. Some people actually teach this block of instruction by actually just plugging in the values for f of x plus h and f of x, or x plus h and x into the function and just straight plug in or substitute those variables in and expressions into the function to get the answer. But what I like to do is I like to break this down into 4 steps. 4 steps. The 4-step process is very good because it helps the students to understand the process of how the actual solution is actually working itself to come to the final solution. So we're actually going to do 4 steps, which will be finding the difference quotient of a function, which also means that you're finding the slope of the secant lines. Okay, the slope of the secant line is nearly similar to the slope of the tangent line, which is the 5th step when you actually apply the limit to this function. Here's the slope. Spell this wrong here. Slope of the tangent line, which is not necessarily required for pre-calculus and college algebra students to learn at the moment. This is considered f prime of x, which is the derivative, and they call it also call this the definition of derivative, which is going to be the limit of f of x plus h minus f of x over h as h approaches 0. Well, in this course, pre-calculus and college algebra and pre-calculus, you're not going to do too much of this topic because you have to learn or go through the process of learning limits, right? So that's a completely different course. That's a course that's going to be learned or taken after you have taken algebra 2, say college algebra, pre-calculus 1, and that sort of thing. So here, I was just basically making a point that you have a 4-step process, which is this here is actually the slope of the secant line. Now, what I was saying earlier, this is nearly similar to the slope of the tangent line, but the secant line is actually a line that goes through, for example, 2 points. So this here is your secant line, right? And this here would be your tangent line. Okay, so basically, I just wanted to just give you, a briefing of what this was about, and I do have videos on finding the slope of a tangent line using the 5-step process. But for this particular video now, we're going to focus on finding the difference quotient of a function by doing 4 steps, which is going to give you the answer of the slope of the secant line. So let's go ahead for right now and erase this portion of the notes because I want to show you a couple examples of the 4-step process of finding the difference quotient of a function. Okay, so here we go. So example 1, we want to find the difference quotient of a function. Find the difference quotient of a function given. Let's just do something that's simple for right now. Given f of x is equal to, let's say, 3x plus 7. Okay, so we're going to use 4 steps. So step A is we're going to find f of x, which is basically obvious the same here, 3x plus 7. Step B, we're going to find f of x plus h. And in C, we're going to find f of x plus h minus f of x. And lastly, step D is going to be f of x plus h minus f of x all over h. We see this. Okay, so let's use a different color. Let's see if we can use blue. So we're going to take f of x right here, this x, and substitute it into this expression here, x here. So we're going to come up with the same thing, 3x plus 7. So that is our solution for f of x. Now let's look at f of x plus h. We're going to take x plus h and substitute it into here for x, and it's going to be 3x plus h plus 7. And then we're going to take the 3 and distribute to the x and the h inside the parentheses only. And then we'll simplify where necessary. And this will be 3x plus 3h plus 7. And that's all we need for right now. So that's the solution for f of x plus h. So now we have f of x plus h and f of x. So now we're going to subtract it from each other in this step here. Everybody see this, right? So here this will be 3x plus 3h plus 7 minus 3x plus 7 in parentheses. So I like to put things in parentheses and then of course pull them out. And then of course actually do the acts of distributing. And then we lose the parentheses here. So this will be 3x minus 3x minus 7. So we simplify this by grouping our like terms. And when we group our like terms, we have 3x minus 3x, which is going to be 0. And we have 7 minus 7, which is also 0. So we're just going to be left with the solution of 3h for this step. So f of x plus h minus f of x is equal to 3h. Now we see step 4, we have f of x plus h minus f of x. That equals 3h over h. So guess what our final answer is for this step here? the difference quotient of this function is going to equal to 3. Hence, this is also the slope of the secant line. So your answer to this problem is 3. Everybody see this? Take a second or so, pause the video, and then copy the notes, copy the 4 steps, and then we'll do another example. Now, hopefully everybody has copied down this example. We'll do another example. So we'll erase the board here and erase this example. And what we'll do is I'll keep the steps up. I erased my f of x there, but I'll just write it back up there in just a second. And we'll do a little bit, we'll do a problem that's a little bit more complicated. Okay, so we've gotten rid of the whole thing. So let's do another example here. Let's put our difference quotient up here. Okay, we'll write this in blue this time. Okay, and so we want to find, again, we want to find the difference quotient of a function given f of x is equal to, this time we're going to say x squared plus 2x minus 3. You see that? So we're still going to use the 4 steps to find the difference quotient of this function, which is also considered the slope of the secant line. This is step A, step B, step C, and step D. We see this. Okay, now we're going to see some red here. We're going to find the difference quotient of a function given f of x is equal to x squared plus 2x minus 3. We're going to substitute this x into this expression. So it's going to be x squared still plus 2x plus 3. Everybody see that? Now, this second step is going to involve a little bit of work because you have to do some foiling. So we're going to take x plus 8 and substitute it in here, and x with x here and x here. So this is going to actually be x plus 8 squared plus 2 times x plus h minus 3. We see that. Now, we're going to have to FOIL this because a lot of times students make mistakes and say x squared plus 8 squared. No, that wouldn't be correct because you actually have to multiply this twice because the exponent says so. So we're going to FOIL this. X times x is x squared. Foiling being the outside term, the first term, outside term, inner term, and last term. So we'll say x times h, right? The outside terms. The inside terms is h plus h times x. But since multiplication is commutative, it still could be x times h. And of course, the last term, h times h. So you're going to come up with h squared, and this is going to be plus h squared, xh plus xh, right? Because of the outside term and the middle term. And remember, we said h times x. Yeah, it's the same as x times h because multiplication is commutative. And the last term is going to be h squared. So this is going to be x squared plus 2xh plus h squared. That's for this. So we have h squared here plus 2xh plus h squared, and then we're going to distribute this. This will be plus 2h, or 2x, sorry, 2x plus 2h minus 3. You see that? Okay, so that's what x plus h equals to. So we write this down, and we have f of x plus h minus f of x, so this will be h squared plus 2x h plus h squared plus 2x plus 2h minus 3. Put this in parentheses here. And this is going to be minus, it's a little close here, x squared plus 2x minus 3. I hope everybody can understand that. So I'm going to pull this out, and we're going to simplify this by subtracting both f of x plus h minus f of x. So we didn't make any errors here. So we distribute this here. So this is going to be negative x squared minus 2x plus 3. So now what do we do next? For this problem here, so we're going to group our like terms. So x squared minus x squared is going to, that's going to equal to 0, right? And then we have 2x minus 2x, that's also going to equal to 0. And then we have 3, negative 3 plus 3 is equal to 0. So all we have left here for this difference here, f of x plus h minus f of x, is going to be 2x h plus h squared. And that is our solution for that part there. So now look, so we go down here and we look at the numerator. So that the numerator equals what? 2x h plus h squared. And you can use the division, you can use actually for this 2x h plus h squared divided by h. You can actually use a division of powers, use the power of the properties of powers and exponents to do the division of this, which you know is x to the m divided by x to the m is equal to x to the m minus n to solve this. But it's so much easier to just factor out the h for this last step. Some people use the property of exponents to divide the division by exponents, dividing each of the terms by the same basis with subtraction of exponents there. But that's a little bit more, a little bit longer process. All you have to do in this step here, this last step, is to factor out the h. Factor out the h, so that'll be 2x plus h, right, divided by h. And our last and final thing, when we simplify this, our solution is going to be 2x plus h. That is the slope of the secant line, ladies and gentlemen. So this is your final answer to this problem. This is the difference quotient of the function. This concludes our video, our topic dealing with difference quotient of a function, finding the difference quotient of a function. There will be some future videos in later on with this topic and other uh, calculus, with pre-calculus topics, and as well as calculus topics. I do have also more videos on finding the slope of the tangent line, which is going to be actually the fifth step process to this, when we actually apply the limit to this. And that answer for this, the slope of the tangent line, would be just 2x. But like I said before, since this is a pre-calculus, some of you are learning, have taken college algebra or pre-calculus. You are not required to learn what the fifth step is just yet until you get into the Calculus 1 course. So everybody have a great day and a blessed afternoon, evening, and night. And we'll see you in the future. Bye-bye.